Okay, today we're going to do reflections, which is a transformation. This chapter 9 is on transformational geometry. After this lesson, you should be able to successfully draw a reflected figure and describe the transformation. Those are the Common Core standards. A transformation is a mapping. You have some things to fill in on your worksheet now. A transformation is a mapping of one figure onto another. A transformation can be a reflection, a translation, a rotation, or a dilation of the figure. One of those is not like the others in a particular sense. Reflection, translation, and rotation preserves the size of the figure. A dilation does not. A dilation expands, enlarges, or shrinks it. Or you could put together any combination of those. That's how people make your videos, and they make things move in videos, is by doing transformational geometry to the figure or drawings. Transformations map one figure onto another. The original figure is called the pre-image, and the new figure is called the image. Just like you see your image in the mirror, it is a reflection of yourself. Did anybody still need that page? A transformation in which the original pre-image figure and the image are congruent, and that was what I was referring to a moment ago, is called a rigid motion by the Common Core standards. Common Core standards. Rigid meaning fixed. This means all the length and the angle measures are preserved. Another word for this is an isometry. A reflection is a transformation representing a flip of the figure. That's how we might put it on our words. The line of reflection is the line that the figure is flipped over. Each point of the pre-image and its corresponding point on the image are the same distance from the line. Okay, so if you're reflecting over a line, you're doing an equal measurement to the other side of the line. A reflection maps a point to its image. If the point is on the line of reflection, then the image and pre-image are the same point. If the point does not lie on the line of reflection, the line of reflection will be the perpendicular bisector of the segment joining the 2 points. I have a picture to illustrate that. Let me still need this page. Well, I know you have some words to fill in. No? Okay. This is a picture. So you don't have this on your paper. I'll show you what we were just saying. So you see how C and C prime, okay? This would have been the pre-image, and the one over here is called the image. C has been reflected over the line M, and this line M now, see all these segments connecting the pre-image and the image points? These are equal length right here. Same distance across the line. That length equal to that length. This length equal to this length, etc. All of them are the same distance away from the line. And then this line right here is at a right angle with this line. So when we do our first reflection in a moment, we are going to have to make sure that it looks like this when we reflect it over the line, meaning it has to be coming across at a right angle to the line. So for us to get a reflection line here, I'm going to need to be able to show you how to do it. I'm going to switch to document camera. Sorry. in a little bit. Wish I could make this a little bigger. Okay. All right, so I'm going to show you how to reflect. Got your ruler. Okay, let's use the side with the inches on it. That would be this side. Okay. We're going to line, we need to get our ruler at a right angle to this line of reflection, M. Now, what I'm suggesting is you line up with one of the numbers on here. I'm just picking 5. And you see that little line right here by the 5? I want to make it nice and straight on line M. So I'm going to make it disappear on line M. And then I'm making sure that I actually do have this at a right angle. Okay. So it looks good to me. I'm going to slide over now till I can see point J. Okay, now you don't want to cover it up with the ruler right here. It's got to be visible. Okay. Now, if I count those little tick marks, which happen to be 16ths, how far away is point J from the line? Well, I see it is 1, 2, 3, 4 small 1/16, 4/16 from the line. So go up to the line and go up 4 marks. 1, 2, 3, 4, and make a point. Okay, so I counted again how far I am away. I'm keeping my ruler at a right angle with the line by using the lines on the ruler. I went 4 below to get to J, so I have to go 4 above to get to, and now I label that J prime. I thought I had a light on here. There. Maybe that's better. K is on the line, so K prime will be on the line. Okay, it's still that same point. You can put a dot there if you like. And now we need to measure H over the line. So I'm going to line my ruler up again. Make sure I can see H. And then I'm going to count how many of the small 16ths I am away. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You got 11 16ths away below the line for H. So now I'm going to go back to the reflection line M and count 11 16ths above. Right there, make a dot. Okay, and that is where H prime is. Take your ruler, use it as a straight edge to connect your points. And you've done a reflection of triangle. I think it's nice to look at it this way. I just turned my paper so I could see it like a little bug. All right, when we do number 2, 2 of the points are on the reflection line. So N prime and M prime are right on the line. I got those done quick. Now we got to turn our ruler this direction. Okay, doesn't really matter what number I use to line up, but to see what I'm trying to do here is I want this line where the 4, I'm using the 4 or 5, whatever, I'll use 5 again, to be straight with the line. So I got to slide it and hide it, meaning I want to make sure I don't cover up L either when I'm counting. Just hold the ruler still. Count how far away L is from the line. I got 2, 4, 6, 8, 10, 12, 13, 8 16ths. So I'm going to count 13 to the left side of the line. 2, 4, 6, 8, 10, 12, 13, 16ths. Label that L prime. Connect. Those little tick marks it's called prime notation. Okay? How we do? I mean, if your point is way up here, something strange, you're not lining up at a right angle with the line. So it's got to be, and there's another way to check. If you connect your L and your L prime, you should see it's at a right angle here. And this distance should equal this distance. You can do that over here also. If yours is real crooked, then you need to adjust how you're holding that ruler. Okay? So this is actually kind of how I check work sometimes when I'm doing a quiz to check it. I'm going to connect them, and it makes it visually easy for me to see if you did a good job. Did that, or I put a transparency on top. Okay, I'm going to pop back now to the other modes of operandi. Here we go. Let's go to number 3. Because I don't need that document camera now. This is a lot brighter. Alrighty, we're going to now look at this figure and see what the reflection of segment BH is over the line. So if you went from B, B would flap across the line and become E. H would flap across the line, straight across, and become G. That's how easy that can be. IC, I is in the same spot. It's on the reflection line, so it is its own image and pre-image. And then C goes cross over to D. Name the reflection of segment KA. Segment KA would become FA. And you do have to have the letters in that order. It matters. Okay, so F flops over to K flops over to F, A's itself. Pardon me? Why wouldn't it flap for ID? Okay, IC is because I would stay there. I know that. So A's in the same spot. So I'm not sure what you're asking me. Okay, just a second. Okay, now that we cleared that up, angle C. Angle C crosses over to angle D. And name the reflection of angle, it was angle KAI, right? And that's here, KAI. If you flipped it over the line, it would be FAI. Angle FAI. Okay? Drawing reflections in the coordinate plane can be performed. You can reflect all over the place in the coordinate plane. It's actually kind of nice to do it there. Each point of the image and its corresponding point on the pre-image must be the same distance from the line of reflection, just like we did when we measured. To reflect a point over the x-axis, multiply its y-coordinate by -1. Okay, I'm going to show you why. So if you have a point and you want to go over the x-axis, which is here, and there your point was right there, it's going to flip over up to here. So what's going to change? The y value of the point. Make sense? So that's why they say multiply the y coordinate by -1. So the y's will change sign. If you're going to reflect over the y-axis, which is the vertical axis, what's going to change? If you're over there, you're going to flap over to here, and that would change the x value. That's why it's multiply the x coordinate by -1. And if you're going to reflect in the line y equals x, which is this line, if you're going to flip over that line, say your point was here, it's going to go across to here. What happens is you switch x and y. Interchange x and y. So let's do some. We're going to plot the quadrilateral with vertices D, E, F, G at -2, 3. Label it D. 4, 4 for E. 3, -2 for F. and -3, -1 for G. You can use your ruler and connect the points. And then it says to do a reflection in the x-axis. Okay, so I'm going to highlight the x-axis. Oh my. There's my x-axis. So you could use the rules. This is the symbols of what to do. Change the sign of the second letter number. So D prime should be at -2, -3. E prime should be at 4, -4. All I'm doing is changing the sign of the y's. F prime would be at 3, 2. And G at -3, -1 will be now at -3, +1. Well, that only makes sense, and you don't really need to know that rule if all you do is look at this thing and say, well, where is D? It's 3 above the x-axis. So if that's 3 units that way, we're going to go 3 to the other side, and there's where D prime would be. Now, you don't have to make that line. I was just kind of showing you what I was doing. So E is 1, 2, 3, 4 above the line, so I could do 4 below the line. 1, 2, 3, 4. Oopsie, that's an awful big point. E. I see that F is 3 below the x-axis, so I'll make a point directly straight above the x-axis, 2 away, the same distance away from the reflection line. And G is 1 below, so let's pop G prime, 1 above, and then connect the dots. And again, I do not really want that line drawn in there. Okay, get rid of it. And that's our reflection. All right. Are we ready for the next one, or does anybody need this still? Okay, we're going to graph FGH. Let's plan on putting F at the top, please. G at the right and H at the bottom of the triangle. This time it says to reflect in the y-axis. The y-axis is the vertical axis. So that's what I'm going over. Okay, I look at the figure and I say, well, there is a rule for it. F is at -2, 5. H is at -3, 1. And G is located at 5, 2. What we have to do when we do a reflection over the y-axis is change the sign of x. Change sign of x's. So the new point F prime should be at 2, 5. H prime should be at 3, 1. And G prime should be at -5, 2. Well, why don't we just reflect it? It's F is 2 to the left, so go 2 to the right. There's your F prime, and that is at 2, 5. H, 3 to the left, go 3 to the right, and there's your H prime, and that is at 3, 1. And G, coming right back here, G prime is at -5, 2, and we will connect our points now. So you're going to have to be able to give the answer even graphed or not graphed all the time when it says to go over the y-axis. Okay, anybody need me to wait? All right, now we're going to reflect over a line called x equals 1. Now, we've been graphing lines recently, and that's part of why we reviewed it already. X equals 1. What kind of line is x equals 1? Vertical. Good job. Well, then it's here. There's your vertical. There's your 1. So I'm going to make a line vertical through 1. This is the line x equals 1. Let's label this FTH. Okay, now I need to ignore the x and y axis to do the problem. I have to just do it because there's no rule for going over x equals 1. I just look and say, well, g's 2 to the left, so let's go 2 to the right and make a g prime. Okay, it's 2 to the right of the green line. Now, where's f compared to the green line? 1, 2, 3, 4 to the left. So we'll go 1, 2, 3, 4 to the right of the line. It's just got to be the same distance away from the reflection line. H is 3 left, so we go 3 right, staying at on that line. You have to be staying on the line between the points like that. Okay, and then connect. Oh, it's not a very good line I made there. Make some with my nice tool. Oops. All right, it's just behaving badly. Oh. Oh well. Me and my blank slate. All right. Good enough. Anybody need this still? Oh. Reflections are kind of fun. Well, as far as math goes, I know. The x-axis we're going over. So let's highlight the x-axis. Let's label this guy, starting in the left-hand side, E, F, G, H. Let's take a trip over the x-axis with each point. And the rule is actually to change the sign of the y's, but why not just do it? H is 2 below, go 2 above. F is 3 above, go 3 below. So just going to the opposite side. And then connecting the points. I want that. I'll take this. Can you imagine back in the day when I didn't have all this technology, we didn't have this fancy thing to write on and all that. I had to draw this stuff on the board. Took a lot longer to get lessons done. Okay, y equals 1. What kind of line is the y equals 1 line? Horizontal, where y is 1. That's y equals 1. Say that again, please. Because that's stuck on the line, right? So let's make that E, so E prime is going to be in the same place. Let's do E, F, G, H, going around again. So E prime is on the line, like you said, so it stays there. F is 2 above the line, so we got to go 2 below for F prime. He's only 1 below, or excuse me, it's 2 below the line, Heimer. So we need to go 2 above the line. And H is 1, 2, 3 below, so go 3 above. 1, 2, 3 to H, and so up 1, 2, 3 from the line. Are we okay? And there she is. I don't know why it's colored on it. Okay. Now it says graph each figure in its image under the given reflection in the x-axis. All right, we get to plot first again. The rule, if you're going to go over the x-axis, is to multiply the y's, multiply the y values by -1, or change the sign of the y values. The d prime will be at -2, 1, e prime will be at -1, 3, and f prime will be at 3, 1. So let's get the DEF plotted first. Okay, said to go over your x-axis, which is the horizontal axis. E is 1 below the x-axis, F is also 1 below, so we go 1 above, and E is 3 below, go 3 above. And those should be the same points that I listed. -2, 1, yep. -1, 3, and 3, 1. Hope we're feeling pretty good about this. All right, let's go for 14. 1, 4 is where A is. 2, 3 is where B is, and -3, 1, C. Now this time we're going to go over the line x equals y. So I'm going to try to get you to understand why the line x equals y is where it is. X equals y means that numbers match in the ordered pairs. So if you think about it, 0, 0 would be on it. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, anything with, same numbers. -1, -1, -2, -2, -3, -3, -4, -4, so that's the line x equals y. So now just intuitively, if we want to go over that line, we can see that B is like half a diagonal. It's probably going to be right there. Now, what my point is there is a rule. And the rule says to switch x and y, interchange the x and y values. So A prime, instead of being at 1, 4, it's going to be at 4, 1, B prime, 3, 2, and C prime, 1, -3. So all I did was switch these guys. And that's the points I would have. So let's see, 3, 2. Oh, yep, that's where B landed. This is B prime. A, 1.5 diagonals away, should be here, 4, 1. And C is 1, 2 diagonals away, so I went that way. There would be C prime at 1, -3. Well, that I did not draw very nicely. My tool. Well, that's not what I wanted to happen. All right. Start over, Heimer. There we go. I am going to There we go. Now, finally, got my tool. Ooh. Only as good as the person using it, though. All right, that's it. Now, there could be questions like the following. Casey drew this triangle on the coordinate plane, but you're not going to get to see it. What are the vertices of the image of this triangle if it's reflected over the y-axis? So if it says over the y-axis, we have got to know the rule, which, again, use your head. If you're going to go over the y-axis, boom, 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 you're going to go over here, and that means that the x's change sign. Okay, so you have all these points, and all you do is change the sign of the x part, which is the first part. So A prime would be at 2, 5. B prime would be at negative 5, 2. C prime would be at 3, 1. Pretty easy. Okay. Not that hard to actually remember on your own either. Now, in part B of the problem, it says that he went over the line y equals x. That's when you switch x and y. All you have to do to write those coordinates would be to flop the points. 5, negative 2 would be A prime, 2, 5 would be B prime, and 1, negative 3 would be C prime. I know I write fast. Okay, are we good? This next question says, explain in words how to find the image points when you reflect over the x-axis. And remember, if you go over the x-axis, you went from here back down to here maybe, you are changing the sign of the y's. You can say change the sign of y values. Or you could say multiply y values by negative 1. All right, so the next part's your homework. Please use the opportunity right at this moment to do your reflection of the numbers 1 and 2 since you have a ruler with you right now. Okay? And I'm going to sign out of Heimer Time YouTube video. Have a nice weekend. Or, well, if it's not the weekend, then have a nice evening.